As for the instantaneous speed at t equal 2.7 seconds, applying or substituting in the speed time equation, we have v equal at plus v0, a is minus 1.6, 2.7 is the time, and v0 is 20. We get the following answer. For the second exercise, the graph below shows the variation of the abscissa as a function of time for a moving body. Find the speeds of the car VA, VB, and VC at point A, B, and C. So they are asking here for the instantaneous speeds at different times or at different positions. From the graph, at A, VA is halfway between 20 and 40, so it is 30 meters per second. VB is equal to VA since they belong to the same horizontal line. So VB is equal to 30 meters per second. And VC, the corresponding speed is 0 meter per second. Now calculate the acceleration of the car along OA, AB, and BC. Here we have to take into consideration the calculate the acceleration. Here they mean they want the average acceleration. So average acceleration for the whole phase, as you can see, the speed is varying. In the first phase, it is increasing. In the second phase, it's constant. In the third phase, it's decreasing. So they're asking for the average acceleration. The average acceleration is equal to the difference in the speed over the difference in time, and it's v final of this phase minus v initial of this phase. So it is A for OA is VA minus VO over TA minus TO, 40 minus 0 over 6 minus 0, why 6? Since the time needed for this phase is 6, C2 for 6 seconds. So we get the answer 6.67 meter per second square. For the second phase, which is from A to B, it's VB minus VA over TB minus TA. The time between these two positions is, here is 6. So having 2, 4, 6, and 8. So the duration of this phase is 8 seconds. And 40 minus 40 over 14 minus 6 is actually 0 over 8, which is 0 meter per second square. And the acceleration of VBC, or the acceleration of the phase VC, is VC minus VB. It's the final minus the initial over TC minus TB. TC is 24 and TB is 14. So the difference in time is 10. We have 0 minus 40 over 24 minus 14. It is minus. What is the nature of motion of the car in each phase? For OA, since A is positive, then the motion is UARM. And this is not enough. We have here to add something which says that since A is positive and V versus T for this phase is an increasing straight line. So we conclude that it is UARM. It's not enough to have A positive, okay? For AB, A equals 0 meter, then the motion is URM. No acceleration, so the speed is constant. And for BC here, we can add V versus T is a horizontal line. Here we can add it. Here it is necessary. For BC, A is negative. Okay, fine. This is not enough. Okay, we know that it is decelerating, but is it decelerating uniformly? This is the point. So A is negative. Having A negative tells us that the motion is decelerating. But is it decelerating uniformly at the same rate? The other hint here is that, or the other evidence here is that V versus T is a decreasing straight line. That's why we can say it is uniformly decelerated rectilinear motion. Again, here it's not UARM, it is UDRM. Calculate the distance covered by the car in each phase OA, AB, and BC.